I am Joanna S. Lucas from BSCE 1E, and this video is for my subject, Physics for Engineers. Hi, I am Joanna S. Lucas from BSCE 1E. This video is for my subject, Physics for Engineers. Nature always produces a pair force, and nature never produces one force or single force at a time. Or we can say that every interaction involves a pair force exerted on the interacting objects. This pair force is called action-reaction. And that is how third law of motion goes. After knowing the Newton's third law's definition, we can now solve a problem about it. Our problem is there is two boats with occupants meet while in a lake. To separate the boats, a person in the boat 1 pushes on boat 2 with force of 46 Newton. The mass of boat 1 and its occupants is 150 kg, and the mass of boat 2 and its occupants is 250 kg. And we have two questions that we need to answer in this problem. First, find the acceleration the push gives to each boat. Second, what is the separation of the boat after 1.2 seconds of pushing?
Like what we're always doing, we will draw first our problem. Since it says there that there are two boats that meet, so the person from boat 1 pushes the boat 2 to separate it. This will be the boat 1 and this will be our boat 2. Since our boat 2 is heavier than boat 1, so it means that there are more people on boat 2. So let's draw maybe a 4 person in boat 2, and in the boat 1 we will just draw 2 persons since 2 is heavier than 1. So it says there that from boat 1, the man from boat 1 pushes the boat 2 for the boat to separate.
After we draw it, or after we illustrate it, we can now use a free body diagram. So this will be the force that 2 have, and this is the direction of boat 1. So after that, we can apply a x and y coordinate. Since they met here in the middle, this middle will be its origin and x and y coordinate. So this will be our x-axis, and this middle will be y-axis, or this will be the origin. So the boat 1 is going to the left side of the x-axis. So this boat 1, we are expecting this to have acceleration that is, or a force that is negative. We are expecting from boat 1 a negative force. So since it is going to the left side. So in boat 2, we are expecting this, or this will be a positive force, or it has positive force. So after we did this, we can now know, or we can now identify our givens. Boat 1's mass is or we can use a m sub 1 for us to easily identify which is the boat 1 and what is the given in boat 2. So mass sub 1 or m sub 1 is 150 kg. And for boat 2, or we can say m sub 2 for boat 2 is 250 kg. For force, it is said there that there has 46 Newton or 46 force happen. So our force will be 46 Newton. So for force 1 or for force in both 1, it is negative 46 Newton. Since both one direction is in the left side of an x-axis. And for our both 2, or we can use F sub 2 for our both 2, it is 46 Newton. So after we identify the givens, we can now solve it using our formula, which is acceleration is equal to summation of F over mass. So for us to identify it again easily, we will use sub 1 and sub 2 for each boat. So first, we will solve for acceleration in boat 1. So acceleration sub 1 or A sub 1 is equal to summation of F sub 1 over mass sub 1 or M sub 1. So our acceleration in sub 1 is equal to summation of F sub 1, which is negative 46 Newton, and for M sub 1, it is 150 kilogram. So since Newton is equal to kilogram and meter per second squared, we will use that for us to cancel the kilogram. So negative 46 times, or negative 46 kilogram times meter per second squared over 150 kilogram. So let's cancel the kilogram. So A sub 1 is equal to negative 46 meter per second squared and over 150. So our A sub 1 is equal to negative 0.31 meter per second squared. Since, like what I've said earlier, our acceleration in both 1 is negative since it is in the left side of our x-axis where we can find the negative sign or negative direction. So for our both 2, we will use A sub 2. So A sub 2 is equal to summation of F sub 2 divided by M sub 2. So we will substitute it. So A sub 2 is equal to 46 Newton or 46 kilogram times meter per second square for us to cancel again the kilogram, for us to have the unit of acceleration, which is meter per second square. So 46 kilogram times meter per second square over 250 kilograms. So we will cancel the kilogram. So A sub 2 is equal to 46 meter per second squared divided by 250. So our A sub 2 is equal to 0.18 meter per second squared. So we already know the answer in letter A, which is the acceleration of each boat, which is A sub 1, or the acceleration in both 1 is negative 0.31 meter per second square, and for acceleration in both 2, which is 0.18 meter per second squared. So after that, we will now answer the question in letter B, which is what is the separation of the boat after 1.2 second of pushing. Since we are asked here the direction or the separation of two boats, and it gives us a time which is 1.2 seconds, we will use the equation from kinematics, which is x is equal to x sub o, or initial position, plus v sub o, or initial velocity, times t, or times time, plus 1/2 times acceleration times time squared. So since our initial velocity and our initial position is at the origin, our initial velocity and initial position will be 0. So let's write here in our given, initial velocity is 0 and acceleration or x sub o or initial position is 0. And let's also write the given time, which is 1.2 seconds. So we will cancel now the x sub o and velocity and initial velocity times time, since this is just equal to 0. So our equation now is 1/2 times acceleration times t squared or time squared. So here we will use this equation for each boat. So we will write the sub 1 and sub 2 for us to identify it again easily. So x sub 1 for boat 1 is equal to 1/2 times a sub 1, which is the acceleration in boat 1, where what we get earlier, which is our x sub 1 or our a sub 1 is negative 0.31 meter per second square times t, which is the given time for letter B. So let's substitute it. So 1/2 times a sub 1. Our a sub 1 is negative 0.31 meter per second square times our time, which is 1.2 times 1.2 second squared. So calculating this, 1/2 times negative 0.31 meter per second square times 1/2 times 1.2 second squared is equal to negative 0.22 meters. Since we cancel here the seconds, that's why we just get unit meters, since this is a separation of the boat or the distance from the origin. So in boat 2, we will use x sub 2 is equal to 1/2 times a sub 2 times t squared. So x sub 2 is equal 1/2. So our a sub 2 is 0.18 meter per second squared. So 1/2 times 0.18 meter per second squared times our time, which is 1.2 seconds squared. So since we have here second squared and here is also second squared, we will cancel it for us to have meters for our unit, since this is, like what I've said, this is the separation or the distance between the origin. So x sub 2 is equal to 1/2 times 0.18 meters times 1.2 squared. So our equal here, or our x sub 2 is 0.13 meters. So for us to find the total separation for each boat, we will subtract x sub 2 minus x sub 1 for us to get the equal separation or the total separation for the boats after 1.2 seconds of pushing. So x sub 2 minus x sub 1.
Pushing. So x sub 2 or x sub 2 is 0.13 meters minus our x sub 1, which is negative 0.22 meters. So 0.13 meters minus negative 0.22 meters is equal to 0.35 meters. So the separation of the boat after 1.2 seconds of pushing is 0.35. That is how we can solve a problem that is asking for its acceleration and total separation in Newton's third law. That's all. Thank you for watching.